Good morning, scholars. Welcome back to the channel. This morning we're going to look at probability. What is probability? So let's read some definitions. Probability is the chance or likelihood that an event will occur. Right? Let me read it again. Probability is the chance or likelihood that an event, that something will occur, that something will happen. What's the chance that is going to happen? Probability is expressed as a fraction in its lowest terms. And that fraction should be, in the numerator we should have the number of likely or favorable outcomes over, in the denominator, the number of possible outcomes, right? So in other words then, in the denominator we're going to have representing all the things that are being considered, all the possible things that are being considered. And in the numerator, the ones that are likely to occur, given the constraints, given the situation in each case. So we have to look, we have to read and see what is the situation for this particular case and see how many of those members suit that situation and express it as a fraction of the whole set of members. So three things to note. If an event cannot possibly happen, if it's not possible, the probability is 0. And if it must happen, if it will surely, absolutely happen, the probability is 1. Because remember, if we have say 10 possible outcomes and all of those outcomes are likely, it must happen, so it will be 10 over 10, which is 1 whole. So no matter how many of the possible outcomes, if they are all likely, if the entire thing is likely, that is 1. It has a probability of 1. It must happen. If it cannot possibly happen, will not ever happen, the possibility is 0. Also, the outcomes are selected randomly. That means you're not looking and picking which one you want, right? So for example, you would put items in a bag and you shake them up and you just put your hand in and you pick. You're not selecting it. You're doing it randomly. So you're leaving it up to chance, right? You're leaving the situation up to chance. However, some things are more likely to happen. So if you have a number of things in a bag and most of them are of a particular kind, you're more likely to choose that one because it's more of them available, right? So the more of the thing you have, the more likely that the thing will be chosen. But you could also put your hand in there and choose one of them that, so you might have 10 of one thing and only 1 of the other, and the chance still exists. It's slim, it's a less chance, but you could still put your hand in there and choose that one thing, right? So it's likely, even if it's just 1 out of the 11, it's still likely. It's possible, sorry. So let's look at an example. The following cards are placed in a box. So we have a box and we're going to put a number of cards. We have 6 red cards, 5 blue cards, 9 black cards, and 8 green cards. 6 red ones, 5 blue ones, 9 black ones, 8 green ones. Whenever we're doing probability, a good thing to do at the beginning is to see how many you have in all, because we know we're going to need to put it over all the possible outcomes. So let's see how many cards we have in all. 6 plus 5 plus 9 plus 8. 6 and 5, 11 plus 9, 20 plus 8. 28 possible outcomes. So we know 28 is going to be our denominator, the number of possible outcomes. There are 28 cards, right? What's the probability, what's the chance that if you put all these cards in the box, shake up the box, the box, sorry, to make it, to even out the chances, right? Everybody has an equal chance. We're shaking it up, give it a hefty shake, and we're going to put our hand in and pick one card, just one card. What's the possibility, what's the probability that the card will be red? What's the likelihood that it will be red? So we're going to have to put the number of red cards over the total number of cards. So since there are 6 red cards, so the probability of choosing a red card will be 6 out of the 28. And remember, we're told it must be expressed as a fraction in its lowest terms. So 6 over 28 can be reduced. 2 into 6, 3, and 2 into 28 goes 14. So the probability is 3/14 for the red card. So what would be the probability of not choosing a red card? If the probability of choosing a red card is 3/14, what's the probability that you put your hand in there and you don't come up with a red card? It would have to be, what's left back out of 14 if you take 3, 11. 11/14 would be the probability of not choosing a red card. What's the probability of choosing a blue card? There are 5 blue cards. So that would be 5 over 28, which is already in its lowest terms. It cannot be reduced. Only one can go into 5 and 28. So this is in its simplest form. The probability of choosing a blue card is 5/28. So what's the probability of not choosing a blue card? 28 minus 5, that's 23. 23 out of 28. That's the probability of not choosing a blue card. What's the probability of choosing a black card? Now there are 9 black cards, so that would be 9/28. And of course the probability of not choosing a black card, 28 take away 9, that's 19. 19 out of 28 chance of not choosing a black card. What's the probability of choosing a green card? There are 8 green cards, so that would be 8 over 28, which can be reduced. 4 into 8, 2, and 4 into 28, 7, so that's 2/7. The chance of choosing a green card is 2/7. So the chance of not choosing a green card is 5/7. What's the probability of choosing a card whose color starts with the letter B? The probability of choosing a card whose color starts with the letter B. So which colors start with B? The blue ones and the black ones. 5 plus 9, that's 14. Remember, it's 2 things now they're talking about. Colors that start with B, the blue ones and the black ones. It's 14 of those. So that's 14 out of 28, and that cancels to a half, since 14 goes into 28 2 times. So you have the probability of choosing a color that starts with blue or black is a half. That's a fair chance, right? 50-50 chance of getting a color that starts with a B. Alright, let's look at another probability question. There are 20 children in a class. 12 are girls, the rest are boys. 18 of the children are less than 10 years old. If one child exits the classroom, what is the probability that that child is a girl? What's the probability that it's a boy? What's the probability that that child is less than 10 years old? What's the probability that child is 10 years old or older? Alright, so there are 20 children in the class, right? We are already told the total number, so we know the denominator will be 20. 12 are girls, so the probability that if a child leaves the classroom, the probability that that one child would be a girl is 12 out of the 20, and that reduces to 4 into 12, 3, 4 into 25, 3/5. the probability that that child is a girl is 3/5. And the probability that that child is not a girl is 2/5. So we automatically know for the boy, because there are boys and girls, but let's work it still. There are 12 girls, so that means 12 from 20, that's 8 boys, 8 out of the 20. 4 into 8, 2, 4 into 25. So there we have it. The probability that it's a boy is 2/5. The probability that it's a girl who exited the classroom is 3/5. And that makes sense, because the students are either boys or girls. It didn't say anything about alien children. There are only boys and girls in the class. So if the chance of a girl exiting is 3/5, the chance of a boy exiting is 2/5. What's the probability that the child exiting the classroom is less than 10? We are told 18 of the children in this classroom are less than 10 years old. So then 18 out of the 20, 2 into 18, 9, 2 into 20, 10. 9/10. And the probability that the child is 10 years or older then would be 1/10. Logically. Because if 9/10 of them are less than 10, then the rest are 10 or more, which is just 1 left. Okay? 1 out of 10, or 2 out of 20. Alright? And that's the basic idea. That's the basic idea of probability. So we get the total number of things, items, people, whatever, and we look at which item is being referred to, and we see how many of those items, and we put that in the numerator. And the total goes in the denominator. So let's say you're given a word, right? So let's say you're given the word education. Education. How many letters are in the word education? 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in the word education. Okay. What's the probability of choose if you put each letter on a card again and put those cards in a box? What's the probability of choosing an O? It's only one O. So the probability of choosing an O is 1/9. And actually, each of these letters is only represented once. So the probability of choosing any of these letters is 1/9. But suppose you're asked, out of the word education, what's the probability of choosing a vowel? The vowels are A, E, I, O, and U. Sometimes Y, but we're not counting Y now, right? So A, E, I, O, U. How many of those letters are A, E, I, O, U? So we have 1, 2, 3, 4, 5 vowels. The probability of choosing a vowel would be 5 over the 9. 5 of the 9 letters there are vowels. Therefore, the probability of choosing a consonant, in other words, not a vowel, a consonant, if there are 9 vowels out of the 9, then clearly 4 consonants out of the 9. D, C, T, and N are consonants. Right? So, if it was a word that had, let's say a letter was repeated, right? If that letter was repeated, what would be the probability of choosing that letter that's repeated? So let's say we had the word egg. So the G is repeated. There are 3 letters and there are 2 G's. So the probability of choosing a G would be 2 out of the 3 because there are 2 G's in the word egg. And the probability of choosing an E would be 1/3. There is 1 E out of the 3 letters in the word E, in the word egg. Okay? So you actually have to count the number of letters, because remember, it's still a possible outcome. Each G would be there by itself with a chance of you picking it. Right? So these are the possible questions that can come with probability. Just remember, to recap, the probability is the chance of something happening. How likely is this to happen? If you go outside and you're looking at the sky and you're saying, what's the chance that it's going to rain today? What are the clues you're looking for to make that prediction? You're saying, okay, let me look at the sky. How blue is it? How cloudy is it? Or you can say, did it rain last night? Did it rain shortly? Those kind of things would help you decide. But something like that, there is no numerical prediction that you would make, right? You just have to do an estimate. You're just saying, based on the cloud cover, you're estimating a half of the sky is cloudy or the entire sky is cloudy. It's more likely, the more clouds there are, the more likely it is to rain from your experience, right? So you're putting experience into it as well. But probability is just the chance. How likely is something to happen, to occur? And we express probability as a fraction in its lowest term, so we have to reduce it. And the total possible outcomes go in the denominator at the bottom, and the likely outcomes, whichever of the items you're referring to, how likely that one is of occurring, goes in the numerator. 3 points to remember. If an event cannot possibly happen, there is no chance of it happening, the probability is 0. And if it absolutely will happen, you're sure, there's no doubt, it positively must happen, the probability is 1. And remember, the outcomes must be selected randomly. So you should not be looking and say, that's the one I want. That's, you either shake it up, you put your hand in, you're not looking, you are not influencing the outcome, in other words, right? You're leaving it up to chance. Alright, if you have been helped by this video, and I trust you have been helped, please just drop a comment to say thank you, miss. I would appreciate that. And I would appreciate it if you share the video so other students can benefit from the information. And if you have not subscribed to the channel, now would be a good time to subscribe. So you can click the bell as well to be notified as soon as a new video is posted. If you check our catalog and you don't see the video you're looking for, just leave a comment so that I'll know which video you want me to do. Thank you for joining me, scholars. I'll see you in the next video.